Hi everyone, Miss Martin here, and today we're going to review energy and how energy is stored. So let's just jump right on in. So our goal is I can explain how people and things store and use energy. Alright, so we're making a pretty big shift from sound waves. This is a brand new unit, and we're going to look at energy in all types, from electrical to the energy it takes to power a bicycle, to how you even get energy in your body in the first place. So let's review Monday's assignment. What does energy mean? This prediction statement. Remember, always type your prediction. I don't want to see I don't know. I know you've got an idea or two up there. Maybe circle back to it, okay? Do you think energy used by people and energy used by cars are the same thing? So I was looking for like a yes or a no, and then your explanation behind it. How do humans get energy? What's one example of a car that runs on food? So in the video, they showed at least 3 different cars or vehicles that ran off of food products. How does a wind-up toy car work? How can energy be stored in rubber bands? And another prediction. The more you stretch a rubber band, the faster an object goes. Why? So I wanted to know your theory behind why the more you stretch a rubber band, the farther and faster it goes when you flick somebody with it. So let's take a look at the answer. So energy, I saw a couple different responses. I wanted you guys to kind of come up with your own. Energy is the power needed to move something. Or another way to say it, it's the ability to do work. Okay? For the prediction, I'm going to leave that blank because that was each person had their own idea. And that's perfectly fine. How do humans get energy? We get energy from eating food, drinking water, sleeping. All of those help to kind of refuel us. What's one example of a car that runs on food? In the video, there was the French fry oil car. There was a chocolate car. I think there was even a soybean bus or van that ran off of soybean oil. How does a wind-up toy car work? In the video, they opened that toy car up for you, and you saw that there was a spring that, as you twist the back of the car, twists the spring, giving it the ability to untwist and the ability to push the car forward. How can energy be stored in rubber bands? By pulling or twisting the rubber band. I'm sure we've all taken rubber bands, pulled them back and launched them, you know, maybe at our younger siblings or something like that. Last prediction question. The more you stretch a rubber band, the faster an object goes. Why? So this is the big answer. You give it more energy when you pull it back, so it releases more energy. So what is energy? Energy is the ability to move or the ability to do work. So in this picture, where does the energy come from? I'll give you a second or two to think about it. So we have Grandma. She's on like a little bike, and then we have the boy behind her pushing her. So the energy for the bike does come from this boy's arms and legs. You can see he's putting in work. His muscles are working to push her. And if we traced back where he gets his energy, we'd have to find out what he ate that day. Where does the energy come from in this picture? So for the boat to go, it's not the oars, it's not the boat itself, it's the lady who is rowing the boat. So you can see she has workout gear on, she's doing work, she is rowing forward and backward to get that boat to move. And then that energy for her body comes from whatever she ate or drank. So we're going to play a little energy scavenger hunt game. So if you can, pause the video. I want you to think of, in this picture, where do you see stored or potential energy? So where do you see that something might have the ability to move? Alright, so go ahead and pause for just a second. Alright, so now that you're looking for places where work can happen, where things can move, you should start to see a lot of options open up here. So let's just start with the obvious ones. We have stored energy in this bus, in the car, in the pickup truck. They're moving. They must have fuel inside their tanks or some sort of energy source, and that makes them go. Now let's get down to the people. So we see here this person on the bike must have been pedaling really hard because he is zooming through that stop sign. So his bike has stored energy. Those wheels want to keep on going. Where else do we see energy? Another one that stuck out to me is this person running here. They're about to either fall or they're chasing that bird. We have another person that's running down here. And then, let's see where else. Another person running over here. Where else is there stored energy? You know who's making me really, really nervous? Is this guy who's standing by the tree. He's kind of leaning against the wall. What I see is if he shifted his body just a little bit, he would go right down to the ground. So leaning or making that kind of shape kind of stores his body with energy. That is energy that wants to pull him down to the ground, and we're going to talk about that type of energy a little later in the unit. What else do we see? Let's see. In order for this traffic light to work, in order for this crosswalk sign to work, somewhere along the line there has to be energy flowing into it to make it move, to make it change. We have energy in the hot dog stand to cook those hot dogs. We have energy in these buildings. You can see there's smoke coming out of this building, and that's producing a heat, which is a form of energy. Same deal. We have energy in all these stores so that the stores have electricity in them, so that they have heat for their customers. Okay? Even just the act of standing up, like this person or this person. You are pushing against the ground, so you are doing work. And if you were to, you would have the ability to jump. And if you were to take away that energy, you would kind of flop on the ground. So all areas of this picture, you can see signs of stored energy. Energy that has the potential to move or is currently moving. Another big connection we saw is that energy equals speed. So same deal in our experiment from yesterday. The more energy you put into something, the faster something goes. When they talked about Michael Phelps, you saw that the more food he ate helped him go faster in the water. So which Twist-O-Matic had more energy put into it? Alright, so we saw the one with the small rubber band, skinny rubber band, then we saw the one with the thicker rubber band. Now, when I spun the thicker rubber band, it appeared to go faster, even though I twisted it the same amount of turns as the one with the small rubber band. But which one had more energy put into it? So the thicker rubber band needed more of my energy put into it. It was harder to turn. I had to keep on twisting it. And it was resisting each time I turned it. It kept on wanting to turn back and immediately release that stored energy. To get the same amount of spins, I had to turn the thin rubber band almost double. But which one had more energy when they were spinning fast? When both of them were spinning at their fastest speed? So the big thing is, one way or another, the same amount of energy had to go in to each ride to get the fastest speed. It was just the energy was put into it a little differently. For the thin rubber band, I had to turn it a bunch, which meant my hand kept on going back and forth, back and forth, back and forth, until finally it was all spun up. And for the thicker rubber band, I had to turn it fewer times, but the muscles in my hands had to exert more of a force to get it to twist. So, for these two different rides to go the same speed, the same amount of energy over time had to be put into it. Maybe one had to be turned a little longer, but in the end, if we were to calculate how many calories I burned by twisting those to get them to go the right speed, I would have burned the same amount of calories. So, when we're done here, you will have a couple questions to complete on the Edpuzzle. You can finish that, and then you don't have to worry about typing in that Google Doc assignment. If you have any other questions about energy, stored energy, the potential for energy to do something and to work, feel free to record a Flipgrid and I will get back to you. Thank you for joining me.